Okay. Hello, welcome back everybody. It's Liv. And today we're going to just you keep working on language development. Why not? Okay. So um I have a to-do list. So let's just take a look at that real quick. So I need to go into my project folder. Okay. So we are working towards Automate version 4. Okay. So I've done a lot of work on this, but it's still not, as you can see, it's still not quite 50% of the way there, right? We've made some progress, but it's not safe to celebrate yet, right? So, okay. One of the things I have to do is I'm sort of working on utilizing my programming language Peso as a intermediate representation between languages, and if possible a language I can use to translate into other languages, for instance from C to Python or things like that. So I'm not entirely sure how I'm gonna do it, but I'm gonna do it. That's basically what. So okay, for now I'm working on parsing it more efficiently, so that's what we're going to be focusing on right now. Okay, so this is the point I want to work with. That's defining type declarations. And just to be absolutely clear, we're talking about the LPS. So that's the language pattern syntax. And I can show you what that looks like. Let me just turn the volume down just a little bit so I can hear myself. Okay. So I'm not sure how long this is going to be, but hopefully not a lot. Okay. So anyhow, let me move this, and I want to go into PLPS, Pesuga PM. LPS, I'm sorry. So okay, as you can see here, we have a, well, you probably cannot tell what this is, so I'm going to explain it to you. Basically this beg directive in here is telling us here's a pattern, right? So here's a pattern you need to match, and we can build this out of different tags, and tags is basically at the lower level a list of patterns, patterns that can be found in our language definitions. Okay, go in here and I go into, I think it's init, somewhere else. Here we go. Okay, so here's the initialization for the language definition. And in here, as you can see, we have types, specifiers, reserved names, intrinsic directives, built-ins, etc., etc. And so we can match these types of patterns with, as you can see here, with type and spec, right? So this is for type and specifiers. Array, that's for arithmetic, so basically operations, right? Num is for numbers, and bare words, it's basically anything that's a valid name, right? So basically something that's an underscore, A to Z uppercase, A to Z lowercase, and not a number, not on the first character. On the second character though, yes, it's allowed. This is basically what, okay? All right, we have some idea of what this is, right? So we can create a pattern. We can say, you have to match either of these. This symbol simply means give it this name, right? So to this element, name it value, right? And that's that. And that will appear as value match, right? So anything that matches this will appear in our syntax tree, in our parse tree. It would appear as on the value, right? And then this here simply means when you encounter a comma, go back, right? So basically, if you encounter a comma, that means match another one of the last item. So that's pretty much it. The question mark is to specify that an object is optional. The minus minus means go back to the previous pattern. Here we're just renaming this, and the tilde here, the ASCII tilde, what it's telling us is do not report this, right? So in our parse tree, the comma will not appear, right? So it's sort of like invisible, so to speak. Here we have another one of these, and this operator, the whole thing is these 3 characters, it's a single operator. What this means is space is required, right? So the type and the specifier must be separated by space. Likewise, specifier and the name must be separated by space. The specifier, of course, is optional. And for now, we can only have one specifier. I might change this in the future. I'm not entirely sure. Here we are just matching a name, and here's the comma-separated list again. As you can see, we give these patterns a name, which means that later on we can create another pattern and utilize this. And so what will happen is this breaks down into an object, and that object will expand into this. And if in here it will, if it finds another object, it will expand into it as well. So it works recursively, so to speak. Okay. So what do we have here? This is basically telling us what's the type. Type specifies a name of a particular value, and then we give it a value list, right? Because we declare things like so. Say, for instance, you have char a b, and then you give it values 0, 1. Likewise, you can just leave it empty, and it will just pad it out with zeros. If you just have it like this, pad it out with zeros. If you have one name and 2 values, what will happen is it will automatically generate from the last name given. It will say, okay, so A is 1 and A plus 1 is 0, right? So like the memory slot immediately adjacent to A is the value immediately adjacent to the value we've given A. Likewise, if we put say a 5 here, then implicitly A plus 2 will be 5. But we declare it like so, right? So that's kind of nice. Okay. So as you can see, the first 2 we declare as simply pattern. Okay. So there is nothing special about pattern. It is not used by the parser by itself. However, these special pattern types, such as pointer decal, these are used by the parser, and I can show you. If you go into the plps parse function, we can see that, well, first and foremost, what it does is it breaks down the expression utilizing the old system, which is basically just a syntax tree, right? So it's like a syntax tree or abstract syntax tree. I'm not 100% on what's the difference. It's a bunch of nodes, okay? So anyhow, and then it uses the new system, in conjunction with the old. And what it does for now is it's iterating through the list of how to say, of special patterns and trying to match with one of those. So a to do, like yeah, it's right here. We should find a likely pattern to match the expression at hand, rather than just iterating through all of our patterns. But for now, this is good enough. Finding the most likely patterns first. That would be an optimization to do later on. It's not a priority right now. It's not a top priority. But anyhow, what I want to do is to make the pattern for type declarations, and I can already begin typing it out because I know what it is. So And this is not highlighted because it's not within the language definition, so I actually need to open that up. So yes, PLPS it is very much a language right now. It is very much a language, you could say, because I mean it has a syntax file. It sort of executes, we could say. I mean this you could think of it as a program, or as function declarations in a program. But you know, it's not entirely a you know, I call it a language, but it's not entirely a programming language, as it doesn't have like flow control, but it lets you declarate sort of like functions. But, you know, yeah, it is a language for extending regular expressions rather than a programming language. It's a regex language, right? So okay. You know, some people say regex flavor, but I think that's a very dumb term to use. So yeah, okay. So we just add in here type decl, and we need to regenerate this. So yeah, let's do that. Let's go into automat, and I'm going to make the. I'm going to zoom out a little bit, and I think I need to do. Can auto do it? Let's see. So that's PLPS. Actually, let's just close and reopen. LPS, pursue LPS, and no, not quite. So I guess I need to run it manually. No problem. Let's just RPH and Cygen, and that should do the trick. Okay, so let's reopen, and that should be PLPS, pursue LPS, and it's still not highlighted. Wait a second. This is not quite right. This Cygen is right, so it's only generating for PLPS. But it's not generating for PLPS, so this is a problem. This is a very big problem. I need to change the extension. Right. There we go. So it should be, if I'm not mistaken. Let me just check something real quick. Yeah, so I do not need to put in the dot. Okay. Okay, so this should do. Maybe. Let's see. Let me just close this. There we go. Okay. So yeah, right, because the extension it used to be .p.lps, but then I realized, you know, having two extensions, it's kind of stupid, so I just changed it to lps .lps. So yeah, you know, changing that fixes the problem. Okay. So let's close this. Clear. And I want to go into the LPS. Perso LPS. Okay. So, oh, I need to reopen Nano. Right. I need to reopen Nano. Oh, that's so inconvenient. Okay. All right. So we're all set. Okay. So, what constitutes a type declaration in Peso, right? So, first and foremost, what do we mean by a type declaration? What do we mean, right? What are the elements of a type? In reality, there's no single definition. Some people will say a struct, some people will say a primitive, some people will say just a type def is good enough. Some people would say no, it's a full-blown class. You know, I have my own ideas about it. In my view, it's sort of like a block. It's sort of like a block with a certain size that you can replicate, right? So at least as far as the scope of type declaration goes, I would say it has to be oriented towards user-defined types, because primitives are always going to be designer, are always going to be designer made, right? And so we can always have exceptions and you know, and built-in things to work with primitives. But for user-defined rather than designer-defined types, you know, it has to follow rules, right? So I don't have to follow the rules, you have to. So anyhow, the rules in question would be, first and foremost, use the word reg, right? So that's the keyword. I could make it so, you know, it would have to be, I think it's a directive, so I would have to use the, right? But in this case, right, it would accept any directive, and so yeah, it needs to be proc. Or proc, I mean reg. So proc is for symbol declarations. Never mind that. It's not in the menu yet. And we need to use there, okay? So name. And what I'm gonna do is I'm just going to say this is the directive, okay? Just because it makes sense. Now, could we say it will be the exact same pattern for basically every single type of directive? In a sense, yes. But here's kind of the interesting thing. The most basic form of calling this directive would be exactly the same, both for type declarations, scope and declarations, and how do you say, and symbol declarations. But here's the problematic with symbol declaration. For instance, we would need to specify for you know, argument types, argument names, return type, and you know, for namespace, you know, there are other considerations that might come into mind. You know, maybe you want the entire namespace to be, you know, how do you say, encapsulated, and so you have a specifier to say, you know, never, you know, like, how do you say, you have an access modifier, right? That's the name. You know, it's like the word private, public, oops, and protected in C++, right? Good old beloved C++, you know, good old octopus dog C++, you know, lovely language. Likewise, for type declarations, you might have certain modifiers you want to apply. Now, because I'm not entirely sure what those modifiers would be just yet, I'm going to leave that blank. But what we could do is we could have, for instance, you know, the specifiers here, right? We could have them over here, right? So, and make that optional. You could do something like that, but because I mean, specifiers right now are not fully fleshed out yet, and I'm not entirely sure where I want to put them. Yeah, it kind of doesn't make a whole lot of sense just yet. So just roll with it, I guess. Okay. So this is more or less all there is to it. Okay. So let's try it. And I want to go into PLPS parse. And now we're looking for pointer decl and type decl, right? And what we are doing is, and this ties into the PESO rules, okay? So what are the PESO rules? Let me just illustrate. So the PESO rules are the guidelines for what PESO is. And what is PESO? Well, you know, it's a whole ordeal. I could get into it. I could make a whole video about it. So yeah, let me just uh, keep up with this. Peso rule number 4, right? So actually 3 because I count from 0 because I'm, like some kind of maniac. But yeah. Peso rule index 3, no forward decals. So what does this mean? No forward declarations. Namely, if I declare a function right here, at this point in the program, and I want to call a function that's down here, I should be able to do it. So what does this mean at the parser level? It means that we need to do 2 passes, right? So in the first pass, we need to collect all the names. In the second pass, we actually try to interpret the program, right? So that's what it entails, basically. So anyhow, there are a couple more things we need to do. First and foremost, we need to add the fundamental. So what is a fundamental? Is the code that is executed upon matching one of these patterns. So what the PLPS match here is doing is it returns us a key, a tree, a tree, right? So like a parse tree. The fundamental of a of one of these patterns, the fundamental of one of those, what it would do is it would break down that tree, right? So you would need to have a unique fundamental for each one of those. So basically we need to take care of that. So fn dmtl, it's fundamentals. So okay, if I say decomposing, decomposing a syntax tree, a parse tree, you might think, wow, that sounds utterly complicated. It's not, and it's not because I've written tools in order to make it simple. So we're just going to write type decal, and the argument should be master and tree. So master is just a hash reference pointing to program data, like what language are we using, what's the original expression, the original expressions, without processing, things like that. It's just the general information that you might want to look into. It's sort of like a God object, but not really. So let's say my master entry. Okay, I want to take this. Okay, so we named this thing directive, and so we can fetch it saying tree branches in, and actually I have another way to do this, branch values. Yeah, exactly. So we can take branch values, and we need to take directive. Okay, so as you can see, this is that simple. What this will do is it will look at the parse tree, find objects under a branch named as such, and return us all the values. So basically all the values of all the nodes. One more thing, I need to imitate this data structure. Okay. So as you can see, this is actually just a lot of copying and pasting. We could probably handle a lot of this in some third method. I'm only doing it like this, like just copying and pasting just for demonstration. In reality, for these kinds of things, we would either have some form of macro or method that we could call that would basically replicate this sort of boilerplate. But for now, I'm just copying and pasting the boilerplate because that's easier to do. So let me just check out this. Okay. So we have spec and type, and yeah, I think type is good enough. We are not going to worry about specifiers just yet. So I'm going to just leave it undefined, just for now. Okay, all right. All right, all good. Okay, so just one thing, because I think this would be a little bit easier to read. Yeah, because yeah, we're creating an array reference. I want it to be clear. Okay. Okay. So we have the header. Now we need the data. The data for now is just a name. So basically, let's say my data would be out data. And then let's just say, right, it's just an array reference. Okay. Okay. So I guess, yeah, I guess I could do it just like that. And let's actually see what happens, right? And we need to return a reference to out. Okay, nice. All right, so that should get us the tree. The tree, that should be enough to decompose the tree. So now we need a pack, and pack basically gives you like the instructions that need to be executed. But put into an array. Basically, you need to send the object that needs to execute this function, the name of the function, and then the arguments to that call. So that's simple. Okay. Now I don't quite remember how the reg declaration works, so I'm actually just going to check it. Luckily I've already written most of the code, so I don't need to rethink things. I just already have the nodes here and there. Okay, so it should be DST, right? So DST would be like the current scope, right? So the way it works is you have like, it's like a hierarchy. It's not like a hierarchy. Well, in a sense it is, but it is a series of namespaces, right? And so the first one, the base one, is none, right? So basically that means global, right? So global, accessible from everyone. With the clan directive, you can say namespace, right? So this now is your new namespace. So let's say A. Then within A, you can declare a reg, give it a name, say attributes, and now in here you can just declare your values, right? So that's basically that. And this will basically consist a type contained within this namespace. And then if you declare a proc, say instructions, now you can utilize X, right? So let's say copy into X, copy to, something like this. So basically this would be a member method of this class, okay? But this class is contained within this namespace. If you then want to create your main, to do so you just clan none, right? So basically return to global and then write your main. Okay. So yeah, it's quite simple actually. And so DST is basically the current block. Okay. In that chain, right? So if you declare clan, then DST is the clan. If you declare a reg, then DST at that point is the clan, and DST becomes the reg itself, like it's been done in here. So basically I need to copy and paste this. So let me see. We need to change the ST, set a new scope, and set the current block. Okay, so this is more complicated. We also, okay. All right. So there's a few things we need to do. Okay, we need to create a new block, else we need to fetch it. Okay. So well, there are multiple ways I could go about this, but what I'm gonna do is I'm just going to abstract it away into the BL key, into the block class itself. So I'm going to say right from the frame. So what is a frame? A frame is basically like the scope within an object exists, right? So when you initialize an object, you initialize it from the frame, and so you can have certain global values that are not actually global. Their scope is limited to the frame, and therefore only instances of this class created through the frame can access these values, right? So these are like class values that are unique to certain instances, right? It's an object-oriented kind of mindfuck, you know. I kind of invented it, but not really. So anyhow, let's just make a new constructor. Let's say what? New data block. Why not? And yes, I know that I said this is a type declaration, but you know, what does a type hold? What does a type hold, eh? It holds data. And so what do we have here? A data block. Okay. So I'm not sure what the arguments should be, so let's just well, the first one will be the frame, right? So we do need the frame. Just because. We need to find out what the current block is. This is because if you know a reg can be the child of a clan, but if you declare a new clan, then that reg poof. Likewise, you cannot declare a reg within a reg. If you declare a reg, then it goes back to the clan, which is the parent of this reg, and so when you declare a new one, it goes there. When you declare a procedure, on the other hand, right, the procedure goes here. Okay, so you know, just keep it in mind. There is a hierarchy. It is a simplified hierarchy, but there is one. Let me just check this thing. Okay. All right. Actually, I can just say self, but I'm going to say frame. So basically, what we have to do in this case is get the destination. If the destination has the attributes flag set, which basically means it's you can write to this block, which is something more or less unique to data blocks, then you know, in that case, you know, go upwards, meaning go upwards in the hierarchy, because what the current destination is a data block, and therefore we cannot be children to another data block. We need to go up one step in the hierarchy. Okay, so it's that out of the way. So let's continue. We need to do this bit as well. Oops, I didn't mean to comment it out. Okay. That's fine, that's fine. Let me just put separators in here. Okay. So, you know, some people look at my code and say, why the lines everywhere, man? You know, to separate the code, you know, this block does one thing, this block does another, this block does another, right? So you can look at it in pieces that way. You can actually comprehend what is going on. You know, like holy cow. Some programmers don't know up from down. You know, I think I should count myself among them. You know, quite frankly, I think I should, but yeah. Okay. Let me just have a drink here. Okay. We've been at it for about an hour. About an hour. So okay. Aside from all the copying and pasting I've been doing, what's the purpose of this? Just moving code around. Basically, um, we need this function for two reasons. One, when we walk through the type declaration directive, we can use it either to basically say, you know, this block exists and, you know, reserve some memory for it. And also we can use it to later on instantiate a copy of that, right? So if we have a handle to that block, we can create an exact copy of that block. And so this is what this part is about. We need to fetch the block itself in order to replicate it, right? So this is what this is doing. This is what the purpose of this ultimately is, right? And I do need the master, and the master is basically the program itself. So that would give us certain details, like is this the first pass, right? So like I showed you here on the parser, where is it? Okay, so this parsing stage is the first pass, right? So in here what we are doing is just collecting all the declarations, making sure we know every last name present on the file, okay? And so later on, if we want to reference something, we can reference it from anywhere in the code. And thus, we fulfill the default PESO rule, which is no forward declarations. Okay. Oops. So we need to get this information from the program itself. Is this the first pass, or are we later on the process? Okay. In that case, we initialize a new block, and we can just call this from frame. And yeah, we should do an pointer. So again, program would have a list of pointers, and so program will be able to fetch a particular name given the current scope. Okay. So yeah, that's about that. Okay. And this needs to be done again from the frame, right? Because the frame, you know, this would contain all of the blocks unique to a particular program. Every program would have its own frame of this block class, and so you can have and so you can have both this global data, but you can have multiple instances of frame, and so you can have two programs within, you know, two programs in memory within the same process, right? You know, logic, right? So okay. I mean, you see it. Not all sorts of object-oriented programming are pointless, right? So, I attack, you know, very impractical applications of object-oriented programming all the time, like all the time. But you know, when it is useful, it is useful, right? So you know, don't just throw it in the garbage can if it's a useful tool. Anyhow, so what I'm thinking is, could I return something here? I think not. Yeah, right. It's not supposed to return. Still, I think I'm gonna, just because. This isn't right. Wait. Let me just fix something real quick. Let's say options. And if options, actually I can just check. Actually, I don't need options. If it's not the first pass, then we do this. Okay. So what is this fragment about? I'm going to explain it. I'm going to at least try. Consider the first pass of this program, right? When we still, you know, at some point during the first pass, we will not have certainty that all names, that all declarations have already been found, right? And so we might have references to symbols that are not yet declared, okay? And so if we have a call to one of those symbols, or any kind of the referencing of a pointer or something like that, we will not be able, in the first place, we will not be able to find it, right? Because it's not yet declared. It's not within like the list of names, right? It's not within our namespace. We will not be able to find it within our table. And second, if we needed the value either contained within the pointer or returned by a particular symbol, we will not be able to find that value, and therefore we will not be able to execute the code itself. And so, right, so what we do here is, on the second pass, we need to collapse the operator. Now there's some funny thing in here, in that this is not quite right. Okay, so this is assuming that these collapsible nodes are only found within the first entry of data, right? It might not always be the case. So that's something I need to work out better. I need to iron this out. But yeah, for now it serves our purposes. So let's just write that to do in here. Well, or you know, I could do a more thorough iteration of the data, but yeah, let's just leave it to do. I'm not going to do it right now. Yeah, I don't want to say better. Let's say recursive solving of data, right? So I can understand that. You might not understand it, but I do. Okay. No, I think I like it more like this, more stretched out. So let's see, solve operations on second pass. All right. And another thing we need to do then, rather than run, we need to invoke give. Okay. Okay. All right. So that's that. Okay. Okay. So we need to invoke this from the frame itself. So the frame itself is the scope we want to be using, because that is the object that will be executing this piece of code. Okay. We need to give it name, and we don't have any specifiers yet, so basically that's what. A new data block, and we need to pass it yeah, that is sufficient. That is sufficient. I should probably give data always as an array reference. That would likely make my life easier. I can just receive it like data, and then and then the function itself knows how to break it down, right? So you just break it down like so. Done. Okay. So all right, that should somewhat work. Okay. And now we need to just append things here to the call tab. This is just so I don't have to evolve this, right? So if I were to evolve the key received, then I could just take it from here, and if I just did key dot pack, it will correspond to this. But yeah, I don't want to evolve this. I can do it with a simple function table. So yeah, it's easier, and I think it's clear. It's more clear, but who knows. Okay, so let's just see if this runs. No, it's not actually going to do anything, but okay, we have problems. Okay, so 60, 14. So I never declared block. Okay. All right, we have less errors. Okay. So this one goes from that's peso block. Ooh. What did I do? Oh. Yeah, never mind that. Okay. So all right, so it somewhat runs. Let's just Oops. I meant to say at 0. Actually, I could just push, I guess. Wait, data is no, data is not supposed to be a. It is not supposed to be a hash reference. It's supposed to be an array. Okay. All right. All right, and now there's no errors. All right. So now we can actually try and run this code. So and try and actually run the type declaration. So for that, let's just go into our tab, and I have here basically the program I showed you. This basically calculates 2 to the power of 8 and subtracts 1 from it and stores within X. And as you can see, that's basically what's happening. So, right, I say I'm developing a programming language, that's not just in jest, it's what I'm actually doing. Just showing off. But yeah, let's see if this actually works. Okay. Okay, so it actually interpreted this as an array. So, oh, right, because I suppose. No, that's never going to work. Okay. Oh, right. If I need to match this. Oh, I suppose I can just, because I want to check if it's an array reference, but I can just do it like this. If it's not a reference, just skip. Okay. Cool. All right. Okay, and so that works. As you can see, we have our first space in here, and it has like a table of the blocks that are declared, and then it has the blocks themselves. So okay, nice. There's a problem though. There is a problem. It cannot find. Now it cannot find X. So the block is declared, but it cannot be found. So that's interesting. Huh. Well, I guess I can just fix this. So let's see. What's the line? 877. So that should be set B, right? Oh no, the code. All right, so the address is not correct. Let me just go into set B. Okay. All right, so the address it's saving is not the correct address. Oh, that's curious. Let's see. Actually, I can just. Okay. So we. Okay, so we created an anonymous pointer. That's not correct. Because it is declared as a char, right? So the type should be char rather than anonymous. that's not right. Second, its address should be, this address would correspond to this block, and it should be right here. Okay. So it should be at 8 rather than 0. 8 or 16? No, I think 8. Let me just count. 1, 2, 3, 4, 5, 6, 7. All right. Yeah. So it should be at 8. All right. So I should have started counting from 0. Actually, it goes from 0 to 7 and then 8 to 15. But I'm not entirely a computer just yet. Okay. All right. I suppose that the initializer for anonymous pointers is not quite getting the right address, maybe. Okay, right, so it's getting the name of the pointer rather than the address, which is not correct. So suppose it has to do with it's one of these functions in here. It's for the name lookups. It's somewhere around here that it branches off to initializing an anonymous pointer when it cannot match its name. And yes, right. So I think I know. This must be trying to match okay, what? Okay, so let me see. Interesting. Let me just... It's interesting because I wrote this some time ago, so now obviously I don't entirely know. Right, so it's... Oh no, because it's matching against local names, so no, this is okay. Because valid name, if it founds the... What do you call this? The at symbol, it will not like it, but that's the global name of the pointer. So the local name doesn't have this sign right here. So the valid name should be able to recognize it. Here's sort of the problem. Like addresses should be linking towards the address of the pointer, not its name, right? So let me just find this function back. So where is this being called? In fetch. All right. So I would suppose that my very clever, right, this is why. So what I was doing is, because at the point of fetch you do not really have at this stage you don't have like a good reference on the pointer, so you cannot just call it by its local name. You have to sort of reconstruct that. And so what I did is, well, just get rid of everything before the local name, right? But yeah, right, I can't just do that. I actually need to do this globally, I suppose. Not enough. Okay. Right. So it only eliminates the first part. That's not enough. Suppose we can just wrap this. By the way, I'm only doing this so that I don't have to write a while loop. But yeah, I'm gonna have to write a while loop. Just copy and paste. Because it's not gonna want to match it. It's not gonna want to match it. Okay, so let's just do that. All right, let's see what happens. There we go. Okay, and now it works. So fine, we're done. Okay, and it got the name correct. Okay, right, and the address is correct as well. So beautiful. It's set B. Let's just get rid of that debug print, and there we go. Okay. So that's about that. We have, you know, in a sense, type definitions, type declarations, kind of the same thing. You know, the definition itself would constitute whatever code we write within this block, right? So that's what the definition is. If we leave out the definition, then we just get nothing, right? And oh, by the way, that whole value thing, look. What? Wait a minute. Wait. That's not right. Okay. Okay, so he didn't like that. He didn't like me doing that. Okay. Alright, so this breaks easily, right? So it's brittle. Okay, but as you can see, because I declared a new value, but didn't give it a name, right, so now it appears there like that. Let me see if I give it a name, what happens. Okay, same thing. This is curious. And not something I like. Okay, let's fix this one as well, I suppose. Okay, so the name solving is correct. Then what is going on here? Give me a second. Okay, so the address is correct, the typing and the name, that's all correct. But it's getting the value. It's getting the value rather than the address itself. So that's not correct. I wonder. All right, so okay, so that shouldn't happen. It means I also cannot use binary, right? Yep. Okay. Okay, I get it. I get it. The problem is with the value conversions. I can fix that. So let me Let me try. Okay. So if this is pass no numcon, which I know is not the case. So this is going to be one of the nastiest debug prints you've ever seen in your life. I'm not kidding. But we have to do this, okay? I told you it was going to be nasty, okay? Let's see. Yeah, we got no... It didn't even register it, so that's curious. So it registered the values for the original operation, but not for the second value, so that's not quite right. All right. Somehow it is not recognizing that it has to process numcon on this, so that's not good. Either that or the collapse never happened. Oh, the collapse never happens. Okay, all right. Okay, so this is one of the problems, right? In a better world, I suppose I would just collapse the entire tree, and that would be that. But I can't just do that, so yeah. What I need to do, I suppose, is just do more thorough iteration through the values here. The idea would be that within our pack, the third argument would always be data, right? That's, yeah. Okay, so the third argument will always be data, and that has to be an array reference. Now the question is, what is there a rule for what the values of data are? I think not. First I can do it like this. Here I say and it's just reference arg and else. Actually, what I should do in this case I should take the entire thing, right? So I should make an array or something. Let's do that. So this is one of my all-time favorite things to do in life, you know, just recursive algorithms that are not recursive, right? So doing the tail call optimization by hand, right? So this is one of my favorite things of all time, if you haven't if you're not able to tell. Okay, So actually what I would have to do is just on shift into pending, so that would make them pop out first. We need to on shift into pending all elements of arg, right? So basically this. And actually I can write it like this. Okay, so that's good. And so now what I have to do, okay. All right, let's do it differently. So now, while pending, I'm still recording. Yes. Okay. So I thought I had hit the shortcut to stop recording by accident, and that was yeah, didn't feel so good. Okay. So now what we do is we just retrieve what we've been appending to this array, right? So just take from here, and then if the value is a valid node, then we just. So now the question is, how exactly do we overwrite the original value? The answer is we use references. Okay. In this case, we do need a, how do you say, to make an array of references to all elements in the array reference, which is a bit of a mouthful. But let's try it. Should be like this, right? Something like that. Hey, let's try it. So now we can say I suppose that the value at so we dereference the value and we say that value. Okay. Will that work? Okay. All right, so this is kind of crazy. Let me just preach it out. Okay. Dough. Okay, so that was a legit stupid mistake. Okay. Okay, still not right, but okay, so it's giving me weird values. Okay. Do it like that. Oh, right. That's not correct. Okay. Interesting. It should have. This operator should not be there. Which means this one is never processed. So all right, it's a reference. Okay. Right. So if it's not, then oh, right. I need to summon the number conversion manually. Right. So there it is. Okay. So that fixes the problem. Okay. So it's basically this block. Okay. I would like to put it within its own function, just to make my life easier later on. Nums. Oops. Sorry. Oops. Oh god. Right, so here we just actually self, because this class is functionally what the language is. Basically, it's the language definition class, and so basically anywhere we're using lang, we're actually using an instance of this class, and so we can just self. You know, it's just a nomenclature thing, right? So could do it some other way, but I like this one this way. Return value. Okay. I would do it like this. Okay, so now this is just crazy. This is just madness. Okay, so yeah, that's good enough. So that should solve the problem on one front. So what we have to do now now I should send it as a reference rather than returning, because I do need to make this check. If this check does not hold true, then value should not be modified. So yeah, actually forget about this. Okay, it should be lang number conversion. We should send a reference to arg, and we actually need to access it like this. Okay, because this would be a subroutine, not a value. So this is a getter, right? This is the getter, and this is the setter, right? So the difference is just the parentheses. But yeah, we're just gonna do it like this, and hopefully that would work. And not quite, because so it worked for this one just fine, but I haven't. I did not put the how do you say? I did not put this hook into the other side here, so I can close this. What we need to do is we need to say m language numcon and send these reference. Okay. Let's see that. Okay, so that totally doesn't work. Okay, give me one more second. Because I likely missed something here. Right, so I actually need to match it like that. Ah, this is never ending. Oh, I can't. There we go. Right, so, you know, having I suppose I woke up early and yeah, right. My brain wasn't processing things right, but here we go. Okay. This is fine, this is done, and so okay. And so now we have our two values, and now if I give this one no name, doesn't quite work. Okay. Oh, because right, because the plus one here, right, because the plus one is not it cannot be interpreted as a name. And so what I'm gonna have to do is make it so this this is converted into an operation, I guess, or just allow it as a name, but it's not something I would like. So, yeah. Well, let's see. Okay, so this is over an hour and a half, right? So yeah, yeah. I'm not gonna fix this one just yet, but yeah, it's in the menu. Okay, so all right. So we can use the memory we have reserved. So that's good enough for now. Um. Okay. So yeah, we have we can do operations and store the results. Okay. So that's okay. That's enough for now. Okay. So that's it for me. Uh. Have a good one. Bye.